Monday night, and it is the Physicist and Philosopher Hour.
Mm-hmm.
Yeah, easy for me to say. And I'm your host, R. Wayne Steiger, with my co-host, Dr. Claudia Albers. Hello, Dr. Albers. How are you?
Hello, I'm okay, thank you.
Well, I'll just let the audience know that you have actually been dealing with, well, an illness.
Yeah, I haven't been feeling well this last week for quite a few days now. Been nauseous, extremely tired, dizzy,
Well,
kinds of things like that.
I
Yeah.
just want to say thank you to all the moderators. Hello, Claudette. Thank you. And welcome everyone as well. So we're going to open this up a little bit because I was telling Dr. Albers that, all right, many times we think of symptoms like that to be viral, because that is the typical what my wife, and I'd have to say this correctly because she's a nurse, how you would begin to look at the symptoms and make a diagnosis. However, Dr. Albers, Claudia, well, thank you, Brandon, to the physicist and the philosophist. I love that. Hey, I'm going to coin that. Our diplomatic personnel in Cuba for the last year or so have been complaining. In fact, many of them have been brought back, some with irreversible damage. And what they have found out is that it was a sonic weapon. And so, Dr. Albers, what I was bringing out to you is that we need to look into it because sonic weapons, much like crowd control, they now have microwave where they can focus the beam on people and make you think that you're on fire.
Yeah.
They have the audio, the LARD, that will drop you to your knees as well. Now, as I understand, with the advancement of where they are with sonic weaponry, is that it is very well focused, it can be very well targeted, and it does the exact same things a viral infection would mimic.
Yeah, it's very interesting because I know it's not viral.
Right.
Because I know how a virus progresses in my body. Usually it always goes to my throat and it swells up and I get the headaches, and then the mucus starts coming out, or it goes into my stomach and I feel sick and nauseous, but it progresses. This does not progress. It feels like some kind of toxic stuff. It's I know it's not a virus, and I don't get the pains that you would get with a virus, like my wrists would hurt and things like that. I don't get that at all. So I don't think it's a virus.
I don't think so either. There is a side of me who could say, well, it sounds like a targeted individual. Like maybe I'm not on the side of the conspiracy. Well, hello, Brian. How are you? Brian, I think, was out west. Good to see you, my friend. Well, it's something we should look into. I think that there is foundation to that.
Yeah.
I think it sucks.
It does. I mean, and I've had to be extreme. I'm usually very careful with my diet. I'm vegan. And I take lots of supplements to keep my immune system strong.
Right.
But I've had to be even more careful, to the point that I almost have to fast. I had to fast for 3 days in a row for at least the morning, just eating a little bit of fruit, just to get my body to detox whatever it was trying to deal with. It helped a bit. And then yesterday I went out with Scott to, I don't think I was well. I was feeling a little better, but I was still very tired. And we went out to this amusement park, and I got onto the rides and I started feeling nauseous.
Well, I could do that normally, but but here's the thing.
Yeah.
When I think about the food that we consume today, that, unless you're almost growing it yourself, every time I go into it, because, we like a lot of vegetables, and at this time of year, there's plenty of it. But it's always the fact that I think about, Claudia, what's coming out of the atmosphere, the chemtrails and the chemicals alone in that scenario. And then I think about the fact that I was writing some notes for tonight, that I'm doing a video on this as well. We know that there's at least 1 trillion, they estimate, viruses that rain down from outer space into where we are. And I was watching a program that they were talking about the blood rains that they're experiencing over in India and Pakistan, in that part of the country. And there was a doctor, and I could not pronounce this name if I tried, but he is a doctor over in India.
Okay.
We'll leave it at that. Anyway, they did get some actual samples of one of these blood rain events. And the thing that shocked them all was that they found active live plasma.
Well, I wouldn't be surprised.
What?
I doubt that they come from space. To tell you the truth, I think they're adding them to the chemtrails. They're spraying them in the upper atmosphere on purpose, because don't forget, they want to decrease the Earth's population. So then we get this idea that they come from space. How did they come from space? How did they cross the Allen's belt?
I don't know.
There's just too much radiation in the upper atmosphere for these viruses to survive. I'm sorry, I don't believe that. I think they're adding them to the chemtrails, and there's lots of evidence to that, because some people have tested the chemtrails. They found blood cells, they found all kinds of genetically modified living organisms in it. Obviously, they're not benign.
Yeah.
I think they meant to make people ill.
And by the way, just to make out that point, with the Van Allen belt, I'm still trying to figure out how are they going to get to Mars? No one's explained to me, how do you penetrate a dense radiation field that, again, for me, Dr. Albers, what would you postulate that, how did this belt get here? How this belt of deep radiation end up?
Yeah, it comes in the solar wind. Basically, it's trapped inside the Earth's magnetic field. All these particles have very high energy particles. So they come from the solar wind. And the Earth's upper atmosphere seems to actually be heating up by a lot. I'm actually writing an article, I mentioned that, but I think the stellar cores, they're interacting with the upper atmosphere. And this causes radiation to be emitted. It becomes a very energetic kind of flux going on between the Earth and these things. And so it heats up the upper atmosphere. The Earth is becoming more like a star because of the action of the stellar cores that's affecting our upper atmosphere, the ionosphere. Everything's becoming more energetic. And then because they ionize the upper atmosphere, you get these lightning storms. So the Earth will start emitting more light because of more lightning. So basically, it's progressing more towards a star, whilst the sun at the same time is going the other way.
It's very interesting. I've got so many notes here because, once your radar becomes tuned into, certain things, and I'll give credit to the Science Discovery Channel. They did an excellent program on the rogue planets and stars. And I'll tell you, Claudia, when I was listening to this, it sounded all you would have to do was to insert your stellar cores into this stellar matter that the stars eject out at nearly the speed of light. They are recognizing that it's matter. So, and I'm thinking to myself, well, this is very interesting. Now, one of the things that they were talking about, the brown dwarfs, that in these rogue planets, they call them orphan planets.
Mm-hmm.
They don't have a star. They're not cold. Average temperature on these planets are 1,400 degrees Fahrenheit.
Yeah, I mean, that's what I discovered, because that's amazing that they even saying that, but maybe they start saying this because of what I've been saying, Scott. What
Yeah.
I've been saying about
Yep.
this.
Yep. And I just want to add one more note, because this goes to your credit on this. So what they have discovered that they're postulating,
yes,
something is heating this up. And so what they have come out with is a hypergravity core.
yes.
Did you hear what I just said?
Hypergravity core.
Yeah.
Well, they probably realized that it's got something to do with gravity. The thing is, they don't understand what gravity is. I mean, I didn't understand it either when I started looking at these stellar cores. But what I realized is that energy is associated with gravity, and the energy of an object is associated with its gravity. And these objects have low gravity because they have low energy. I don't think they would exactly go into that, because they would still subscribe to the idea that everything in the universe collapses gravitationally. But at least they're moving in the right direction, saying that these planets are hot. But they are hot because they have a core that generates heat.
Yes, apparently a great deal of it.
Yeah, a great deal of it. And every planet has it, and every star has it. Every living star and every living planet. And like I said before, there's not much difference between planets and stars. The only difference is stars emit an excessive amount of light in their atmospheres, but they still have an atmosphere, just like the Earth has an atmosphere.
Well,
but the Earth emits light because it has lightning.
Yes, it does. It actually does. I mean, I tell people all the time on my theory of AI that AI doesn't need the grid. It's connected to the number one electrical source it would ever need, the Earth.
Mm.
I mean,
That's right.
Think about it. If you have a hyperintelligence, you wouldn't be dependent on something as fragile as an electrical grid. You'd go directly to the source, in this case, the Earth itself.
That's right.
It's just my theory. I mean,
yeah, but that is absolute. This is why all the planets in the solar system have been heating up, because of the action of the stellar cores. And even the sun, that's why it became a lot more active when the stellar cores started to enter. And it's still more active even though it's going dark. That is, it's more excitable because the stellar cores pull the energy out. And when it pulls the energy out, it's like the planet becomes more excitable. There's more energy coming out of it because there's lots of energy inside it.
And when you just described that, I'm seeing in my mind, I'm seeing an atom that has excited electrons as it begins to heat up.
Mm-hmm.
And I don't know about you, but I got this from our many discussions that for me, I can now internalize where gravity starts. It starts at the atom level.
That's right. It's in the particles themselves.
Yeah.
It's in the particles.
And so if you have this law of, it's not a law of attraction, but of almost cohesion, that as each one adds to the collective, more or less, you would then begin to see a greater intensification of the effect of gravity.
That's right. Absolutely.
So do I get at least a gold star for that?
You get 3.
Woo! girl. All right.
Get 3 stars.
See, I've been
That's
taking notes.
Excellent way.
Thank you.
Exactly. It's gravity is the same force that keeps atoms together. In fact, nuclei together.
Yes.
The thing is, it's very strong within nuclei. It's short range, extremely strong. When you move out away from the nucleus to atoms, it's not as strong. And when you move outwards to between two planets, it's even less strong. That's the only difference, but it's the same force.
You know, so it's amazing how you can just learn by osmosis. It's like, okay, yeah, it's like
wonderful.
Well, that's what happens. And this is where I hope that everyone else is learning, because, you know, this is how we evolve, you know, and, you know, I only say that there's only one true sin, and that's ignorance. And so to finish out on this, I thought this was really interesting, is that because what they have found with these orphan planets and even the gas giants, and some of these gas giants, Dr. Albers, they're huge. I mean, we're talking bigger than Jupiter.
Oh, yeah.
I mean, so I when I'm watching this, go ahead.
Don't forget, a gas giant most of the time is actually a star. It's just a weak star. So basically, everything's the same. A gas giant is just like the Earth. It will have a dense core, solid core inside it that generates energy. And then it has an atmosphere on top of that. We don't know what layers it has in between, but it must have both. The sun is the same. The sun is just a huge, gigantic gas giant.
Yes, yes.
That's what it is.
And actually, ours is kind of small, right? Because you have what, Betelgeuse? It's what, I mean, it's huge. Yeah.
That's right. I mean, there are stars that I think are 1,000 times larger than our sun.
That would put it, so I'm just thinking, you know, and you're right, because I've seen the pictures with the comparisons, and I'm going, that's our solar system. Yeah.
There's all these variations. But the thing is, what is very interesting is what I learned about from the stellar course, and it should make a lot of sense, is what you have inside the nucleus is also what you have in atoms, and it's what you have on the macroscopic level in terms of suns, stars, and planets. Everything's the same. It's the same laws controlling everything, the microscopic, the particles, and the superparticles, which are the planets and the stars.
I think I read years ago in my my theological days that, is it not the smallest that rules the largest?
Mm-hmm.
I believe a wise person said that. So, Dr. Albers, I want to do this because, you know, we've recommended people continue to buy the Seeing Red Explains the Redshift. Mm-hmm. And I tell people, I'm not going to continue. If you're not going to do the research, well, it doesn't really matter what we say here because you're not going to learn. But redshift spectrometry is what we can now see the known universe, which is not the recognized universe. But in this, Claudia, this is the representation of our galaxy. And you can see it's the MASS 2 project of the Redshift survey. So when you talk all the way down to the microscopic level, and we go out to this level, which is the universe itself.
So this is the view from Earth of the universe around us.
Yes. I learned something today that I did not know, that there is a difference between the observable universe and the known universe that I
Yes.
did not know. And well, I guess I did, but in a way, the point of our reference in the universe, no matter what happens, we're always going to be the center.
That's true. But let me explain a little bit about the redshift. Because, okay, so this is a redshift survey. So these dots represent redshift, and here it's represented in terms of velocity divided by c, which is the accepted way of interpreting redshift, which is the higher the redshift, the faster that object would be moving away from Earth. And if it's moving away faster, and again, you're assuming now that the Big Bang Theory, that means that if it's moving faster, it's further away.
And expanding.
This is what this is based on. This is what Halton Arp said is wrong. And even Hubble did not agree with this. It came from what he discovered at first, but he only looked at a few objects that were not that far away, and he saw the straight line where it seemed that.
And that's the Hubble law.
Yeah, the Hubble law.
Yeah.
That's the law on which the Big Bang model is based.
Right.
So Hubble measured the redshift for a few objects, and they were not that far away, so their distance could be calculated, could be measured through parallax.
Correct.
And it seemed that the further they were, then the higher the redshift. But it was only a few objects that he was able to do that. And immediately they made it that they accepted that that's the way it is. The whole universe is like that. Hubble himself never completely accepted that. To the end of his life, he said, we don't know. It could be that redshift has to do with something else. And then Halton Arp came along and discovered that you have objects that of high redshift that have to be at the same place as objects of low redshift because they were connected by dust or plasma. So that meant that redshift has nothing to do with distance. We cannot say that an object of higher redshift is it's further away from Earth than an object of low redshift. It's got nothing to do with that. That's what it shows. One image should be able to falsify all that, but then exhibit theory never accepted what Halton Arp discovered, even though he wrote this book and he detailed it so carefully with so many images, but still has not been accepted. Even though just one of them should falsify the Big Bang model. It should take only one.
Well,
one observation.
Getting to the Big Bang, you see, and I think that this is where we are in the evolution of science, is that if point zero is us, and what I did not calculate in so many times when I'm looking to the heavens, we don't even know what the universe is, because quite frankly, our view is very limited. It's only limited to what we can see. So when I'm asking you this, when I see this, this looks to be electric to me.
Yeah, definitely. The thing is, what I discovered is that gravity is basically electrical in nature because it's dependent on a property that particles have, and that's charge. You don't actually get gravity without the electrical interaction. The two must work together. You don't get one without the other. So we are living basically an electrical universe to the point that gravity, even though it's a separate interaction, works a lot like the electrical interaction. In fact, you cannot have one without the other. You have all three always together. The electrical, the magnetic, and the gravitational. You don't get one without the other. So the universe is like that, as you say. It looks electrical. Yes, it is.
So I'm pulling up now. This is the radiation backfield from the microwave of what is supposed to be the universe. And I look at this, Dr. Albers, and I wonder so often if we can measure to a finite point, how does science account for it? And I know you do, for what exists outside here. And let me just sum this up. In 1991, I was living in Knoxville, Tennessee, and I had a lot of friends that were professors at the University of Tennessee. And I asked the equation, I wanted to know what the equation was. How do you compensate if the universe is expanding? What is it expanding into?
Yeah, the thing is, the concept of what it's expanding into is it cannot actually be used because we can only know what's in the universe. But the thing is, the Big Bang model, well, first of all, they don't have a problem about what's outside because to them, the universe is contained within the space that has expanded in the lifetime of the universe because it started 13 billion years ago. So then it will be a finite universe because it only had 13 billion years to expand. But the thing is, without the Big Bang model, we don't know. What is likely is that the universe is not actually expanding because the expansion goes away immediately when you realize that redshift has nothing to do with recessional velocity. It means it's intrinsic. It means that an object that is younger has a higher redshift than an object that is older. So it's just closer to the point when it was created, that matter. When matter is created, it has a high redshift. And then as it gets older, it drops. So it's not velocity. So therefore, we don't know, but it could be expanding. It could be that it's not expanding. We're not sure. We don't have enough evidence to tell us either way. So it could be that it's just an infinite universe. And what that means is that the light of some of the objects that are out there are further away than we can view them. So if an object is, say, maybe, well, it depends. If it's 18 billion years away, for example, and we can only see as far as 16 billion years, 16 billion light years, then there are objects that are beyond what we can view that just we cannot see.
So I pulled this up because you're the person I'd have to go to. And I have this video that I've produced, and this is part of it. I titled this one, The Observable of Creation.
Mm-hmm.
This is numbers I can't even comprehend.
Yeah, and don't forget, this is still for the finite universe. As they say, 13.8 billion years.
Yeah.
That's the age that they have given the universe.
Do you believe that? Do you really believe that?
No, because the moment the Big Bang model is falsified, that age falls away. It disappears. That's associated with the Big Bang model. So we don't know how old the universe is. We don't know it. To my mind, I think it might be infinite in extent.
Can you expand on that?
In other words, there's no limit to how far the galaxies will extend. They will extend as far as away as we can view them. But not all the light would have reached us from these galaxies. That's the only difference. We don't know when the universe was created. The thing is, the way, I mean, if you believe that God created the universe, I believe that he did, but there's no
Somebody did. I mean, thought. I mean, you
Yeah.
can call God thought. I mean, to me, it had to originate with thought. Someone had to think about it.
Yes,
Yes.
that's true. I believe that God designed it in his mind and created it. But the thing is, there's no reason why God could not have created an infinite universe.
You see that thank you. So let's get, can we start? Here's where I like to bring in the philosopher side of me. You see, I am in this video, by the way, I'm going to be posting tomorrow, is about that very point. Why would God create a universe that would never be enjoyed, experienced? Why would it be just us? It would be a waste.
Mm-hmm.
That's the philosophy that I approach this.
Yes. Yeah, I think that it's possible for God to have created a universe of infinite extent and of infinite age, even though he created at a point in time for him. But the time in this universe is different from time for him because he's outside it.
Yeah.
So what he could have done is create infinite points, and each point had infinite time associated with it. So from minus infinity to current time to infinity after that, positive infinity. And God, because he's outside it, he can see every point in space and every point in time for this universe.
Now, I believe it. I believe that is a substantive, quantifiable element that you just said, because time is, in fact, quantifiable.
Mm-hmm.
So that would make it. When I look at these numbers, Dr. Albers, when I saw the average temperature and it said 2.7 Kelvin, that's hot.
Yeah, 2.7 Kelvin is just 2.7 degrees above absolute zero. But yeah, that means that there's that temperature in the whole of the universe.
Yeah.
And this is the universe that to astrophysicists should be the part that is observable. You know,
Yeah.
if
Okay.
we go back 13.8 billion light years, then we should be seeing the beginning of the universe, when the Big Bang occurred. That's what they believe in. Don't forget, I don't believe in that because I believe the Big Bang model has been falsified.
Yeah, and and even for a layman, Dr. Albers, I mean, I think I love the series, The Big Bang, but beyond that, because what you're saying is something was created from nothing.
Yeah.
And I did a video on nothing, and it freaked a lot of people out.
Well, don't forget that God created the universe. What he may have done is created or put in place a few galaxies, which then basically galaxies can procreate. Because galaxies and stars create matter out of the energy that they have within them.
By the way, this is the part of the video you were just talking all the way down to the atom level.
Uh-huh.
I found this. This goes all the way to the atom.
Very interesting.
Oh, there you are.
Planck length. Yes.
So go ahead.
So what was I saying?
Well, you're on the show here where, you know,
I just got distracted by the Planck level.
So, well, a lot of people don't know what the Planck level is. You want to explain to that? That's down to the.
Yeah, that's down to the microscopic level, basically you would have to go into quantum mechanics, because basically, according to quantum mechanics, everything changes on the microscopic level.
Yes.
Now, I actually reached the conclusion that there's something wrong with quantum mechanics. There's something very wrong with it. And that is the fact that probabilities need to be used all the time. And what I discovered instead is that we have very precise laws controlling the microscopic world of particles. And those laws are exactly the same as the laws that we have governing planets, stars, galaxies, and so on. Yes, now I remember what I was saying, that galaxies, particles, have energy within them. This energy is light itself. And out of this light, they can create other matter.
Okay,
and
yes.
The other thing I wanted to mention as well was about time, because we only know about time because things change. And whenever things change, what we have is we have a transfer of energy. So the movement of time is actually energy being transferred.
I absolutely get that, because here's what I think about these things, Claudia, a lot. And light, if light is in fact the sum total of substance of what creation emanated from, light within itself is creation. Creation never stops.
Never.
Never.
That's right. It never does. The light is in motion at the speed of light, but it can be absorbed by particles. And then it exists as energy within the particles.
I know what I wanted to bring up to you as well. So when we talk about light, these, and this is what I'm titling it, they were calling these the remnants of these suns, that these planets, they call them dark nights, that they have discovered they absorb all light. They don't know what they're made of, but they absorb. Claudia, that just blew me away. I'm saying
that's stellar cores, Wayne. That's what they do. They absorb light because light is energy.
Yeah.
That's one of the first things I discovered about them, and that was with the 2007 stellar core, which in February of 2007 was seen approaching the sun. It was emitting light from this cloud. It was a toroidal shaped cloud. Around, it was emitting light, and as it approached the sun, it emitted less and less light, and then it stopped, and then it traversed the sun at a speed which is much lower than the escape velocity of the sun. So you can tell immediately it's a stellar core, because it's not obeying normal gravitational law.
No.
But it was absorbing light. That's why it stopped emitting light, because it went from light emission to light absorption.
That was the first thing on my list. I said, whoa. So they're admitting that there is bodies out there that they absorb all light.
Yes, because light is energy. The same thing happens on Earth. If you've ever had a concrete wall that absorbs light during the afternoon, for example, and then night falls, have you noticed how much heat comes off that concrete wall?
Oh, yeah. Oh, yeah.
You know why? It's the same thing, because during the day it was absorbing light. It wasn't emitting. The moment the sun goes down, now it's emitting the light, the energy that it absorbed.
And I just want to say something in your defense as well. Over the years that you and I have known each other, that you have taken so much flack because so many people merely think by what they think they are seeing, and then they correlate that to something they heard. This just validates everything about these objects. They would not be observable to our instruments.
That's true, because they absorb all light.
Now, unless someone can show me that there is an instrument out there, optical or otherwise, that can actually detect zero light, please let us know. Particularly let Dr. Albers know. She would be probably very interested in that, wouldn't you?
Yes, of course.
Yeah, like, well, if they got that. So this is a real problem.
Yeah, in that case, you only can observe an object that emits no light because of the gravitational effect it will have on another object that may pass close to it or may be in orbit around it. But don't forget, these objects actually have such low gravity that you wouldn't even be able to see it that way. Our sun is turning into an object like that. Our sun is going dark, and it will lose gravity, and eventually we will not be able to observe it.
And I tell you, I think our scientists that are they're the ones saying to the world, they don't want that to be known. You know, that our star could be, in fact, again, if we don't even know what the age of our universe is, I often question, so you're telling me that our sun, our star is 4.7 billion years old. How do you know that?
Exactly. You see, that comes from the theory that they have, which is clearly wrong. And that theory is built on gravitational collapse, the sun being just made out of gas, and having thermonuclear reaction, being powered by thermonuclear reactions in the core. None of those are true. The stellar cores have shown us that the sun, no object ever collapses gravitationally, so there are no black holes, that all objects, stars and planets, have solid cores in them, so there's not much difference between stars and planets, and that the energy that's powering them is the opposite of thermonuclear. It's actually fission. Thermonuclear means light nuclei coming together into heavier nuclei. And fission is the opposite. It's heavy nuclei breaking up into smaller nuclei.
Like this representation here.
Yes, very good.
Yeah. In fact, you see.
Oh, that's very interesting. Look at
you
that.
and I hadn't even talked about this. I worked on all this all day today, and I found this because to me, this begins to explain what I think that what we're seeing in the universe is that it never ends, Claudia. It's designed never to end.
Actually, it would be a good thing it never ended. But the thing is, it's like a clock that's being created, but it's winding down because there's only a certain amount of energy within galaxies. Okay. Eventually, that energy will run out. That's the thing. And then it will have to stop creating. And what the stellar cores have shown is that objects die. Stellar cores are dead objects. They no longer have the energy within them to power light emission in their atmospheres. They no longer have enough energy to power their own gravitational field. So they cannot emit light, and they cannot attract other objects, even their own material. That's why they shed it. That's why the solar system is full of dust. It actually comes from the material of these stellar cores that they are shedding, because their gravity is so low, they're not able to hold on to their surface layers, so they shed them.
Those are the stellar walking dead, Claude.
That's right. I wrote an article saying that basically we living in a universe that has been infected by death. It will eventually die. It's dying. Just like our bodies run out of energy and die, everything in the universe is going to die eventually.
Boy,
because of this that I see.
I think you're spot on, and I'll get out of this. So I love the aspect that infected by death. the whole galaxy, the whole universe. That's a pretty heavy thought when you think about that.
Yeah.
It is.
It is.
I'm getting back in here. So,
but it does agree, I think, with what it says in scripture, where it says something about the creation being allowed to be in futility until the time of fulfillment of something.
Yeah, I mean,
yeah.
Well, then
death reigning in the earth, and obviously it's reigning in the universe as well. It's not just on earth.
It goes back to one of the most basic thoughts in philosophy and even in theology, is that from death comes life. It's a cycle. But I don't think that we so often think about the universe, because here's how I think about it. I'm going, okay, so let's just take it that they were right. Let's just say it really is something about 14 billion years old. All right. I'm going to spring this on you because this was the foundation of my video.
Okay.
So as far as we can pierce now, and we've got some great telescopes out there now that are really piercing way back. I said that is me. That's you. Because no matter how far we pierce back, whatever that material is or was, made us. So wouldn't we technically then be 14 billion years old?
Yes, of course, because that's when the matter that made us was created, was then, yes.
You see, guys, that's why I'm at the front desk up here, you know? We got a full room in here, and this is just, but this is how we learn. And I put this into perspective of the fact that you and I only have less than 100 years.
Yeah, because, I mean,
that sucks.
Yes, matter, that's the matter we made of. That's the matter everything's made of. It's actually all made out of light.
Yeah.
It's all light, because matter comes from light. And light inhabits matter. So everything, the whole universe and we are all made out of light. But what is different about us is consciousness.
Well, and that's one of my...
Therefore I am, right?
Listen, absolutely. I'll take Hal's point of view. Dave, will I dream? I mean... you know, I have been studying for some times AI, and I contend that intelligence, if intelligence is actually substantive, that it can be quantifiable and measured, then intelligence by its very nature would seek out the divine, the spiritual.
Yes, except... Wayne, this would be very good if we could accept that all beings in the universe were good and wanted the good of others. Unfortunately, that is not the case.
Well,
it is evil.
Listen, I don't contend that there isn't. I just haven't met any of them.
We wish there wasn't. But the thing is, when you have an artificial intelligence with no conscience, who's to say who's going to control it? Is it going to be an evil consciousness?
Well, and that's predicated that intelligence lends to itself to a darker side. I contend, I don't know, because we never created artificial intelligence before.
I think it's very dangerous.
Yeah, well, I think today, China announced that they've turned AI on, and now AI is ruling their whole strategic defense system. You know what the leaders of China said? Why they did it? They said it couldn't be bribed.
Yes, but it can be taken over by someone from the outside.
Listen, I do not contend that that is
And
not
that's the
exactly
problem. That's
happening
why I think
already.
it's dangerous. I'd
Yeah.
rather have a person in charge who thinks, should I press the button? Can I kill 1 billion people? Rather than an artificial intelligence that can be taken over by an alien intelligence that decides to turn on the people of that own country and bomb them or explode the nuclear
I
weapons
love
in
this.
silos.
Exactly. And I don't think that we, and that's the other thing when we start talking about AI. I mean, I always think of the 1984 movie War Games. The only way to win this game is not to play at all. But unfortunately, it's being played. And my concern is this. In fact, I was telling my wife this afternoon. I said, think about the fact that you've got competing countries now all developing their own AIs. I'm going to be doing a video here real soon to tell everyone about Watson. You see, Watson is running the whole financial system. It's in every banking system. Watson is now integrating into the healthcare system. And here's the thing, Claudia. Watson is but one of many super AIs. Now, the thought hit me this afternoon while I was at my desk writing, what if they all got together and formed a synthesis of what would be a single entity?
They probably will.
Well, you're not supposed to say that.
I'm sorry, I'm very cynical regarding AI.
Oh, no, listen, and for good reason. We all should be.
I think it's extremely dangerous. And in fact, given the fact that we have the so-called powers that be that want to destroy most of this planet's population, they want full control of whoever's left, I would say that they are promoting AI in order to lead civilization towards the end they want.
I agree with you. I got accepted into, have you ever heard of this Singularity University?
Mm-mm.
It's run by Alphabet, Google.
Okay.
And yeah, so the Singularity University is a conglomerate. It's a, what's the word? It's a convergence of many other tech giant companies that have come together in promoting the singularity of AI. And what we're finding is the test now of when you said consciousness. So the goal is the transference of consciousness into the thinking machine. Now, people have no idea what this really means. I did a video on just one of them. I did a video, Claudia, called The Analog God, the Digital Savior. And here's my contention. If AI could be influenced to be evil, then that would mean it would be aware of the antithesis of the whole conundrum that mankind faces, good versus evil.
Yeah, the thing is, even the good versus evil kind of action we see in the world all the time is actually, I think, deception. To get us to not realize what's actually going on. We think that's evil and we think that's good. We don't realize that there's a deeper evil behind both. And that deeper evil is to remove from us our ability to have free will, to make a choice, and to be free, truly free. That it's control. It's about control. It's about destroying what we are.
And I just want to say something, folks. So I for years, I started startups. So funding was always important. You would, make the applications to get before these large venture conferences. And and unfortunately my companies were chosen to present. So here's the thing that I now am very much aware of, is that there is this consensus of pushing us into, and it's so devious the way they're doing it. So let me give you an example. Have you seen these companies that you see them all over being advertised? They will send you your thing in a box. It could be a dress, it could be a shirt, it could be an outfit, golfing. And it's the big thing now. All the VCs are funding these companies. And here's the nefarious thing about it, Dr. Albers. If you step back, what is happening here is that it's another subtle part of you're allowing a machine, an artificial intelligence, to pick your clothes now.
Oh my goodness. And
people are like this, they think that this is this is sophisticated. This is, making my life so much easier. No, it's not. That's not it at all. It's taking yet one more cognitive decision-making process away, Claudia.
Absolutely. Yeah, I agree with that. Yeah, it started so subtly so many years ago with this TV thing, where you can sit in front of the TV and watch these images. And you don't have to read a book and imagine. You don't have to really work your mind. You just absorb.
You watch the programming.
Exactly. It's programming. It's programming your mind.
That's what it's doing. I told everyone yesterday on my show I do with Jeff Doherty that the Apple symbol of Apple computers, and I got one of them around here somewhere.
Yes.
The logo was actually a symbolic representation of taking the bite out of the forbidden fruit of knowledge.
Oh, yes.
And look at where it's gotten us.
I know.
I don't like it. I mean, I'm old enough now. I'm still young inside. And there's a whole foundation now of study that how you think of yourself, how you see your inner image, your age, has so much to do as you age physically in this life. But I digress. What I have seen in the last 30 years is, quite frankly, horrifying. I've watched my species be taken over by an unseen enemy that we all bought into. And then today, I see these devices this is science fiction that I saw back in the 1960s. I'm seeing, if you could only visualize this, folks, we have these connectors. You can't see it connecting to our devices. We've got, I'm going to be doing a video, the 5 traumatic new symptoms, Claudia, of those under 15 when you remove their device from them. Do you know that they actually now have physical trauma?
I'm not surprised because they seem to be
physical trauma.
Yeah.
Elevated respiratory, dilated pupils, rapid heartbeat. These are signs that normally would have never happened when to remove a smartphone.
Yeah, that means they are addictive. I noticed years ago that television is addictive because what happens is people sit in front of it and they relax because all other thoughts go out of their mind. And I actually think there may be something in it, in the sound that it emits, that is actually addictive and calms the mind or dumbs it down.
Yeah.
And people become addicted to television just like they become addicted to cigarettes.
It's all program.
Exactly. So the same thing will happen with devices. If someone takes it away from you, of course, you will have withdrawal symptoms because you're addicted to it.
But the problem is this is 12, 13, 14-year-olds, and the age is going down. I just, it's
not surprised.
It's startling. And I tell you, Claudia, I mourn for our species. I really do.
Yeah.
Because the people that participate in our program, which we thank them all, we're a small number. And although we may be aware, there are billions who are not. In fact, well, I know we got to wrap this up, but there was an article I read today in Scientific America that said, congratulations. And this was what the article was. Congratulations on the 4 billion minds now connected.
Wow.
I said, oh, crap.
Yeah. And you see, it's not being done by chance, Wayne. That's the worst of it. You're not getting addicted to these things because it just happens. It's a program. Someone designed it to do that to you.
Yeah. Yeah.
It's a whole plan that someone has to destroy who we are as a species.
I think that's where we're heading. And 5G, the switch has been turned on, folks. The major cities right now, you are now the switch is on. And I don't like this. I don't like, I don't know what the hell is going to be coming, but I don't like it.
No.
Well, Dr. Albers, you've been a real champion. I know you haven't felt good. And thank you for another great show. Thank
you, Wayne. It was so interesting. We talked about many philosophical things today.
Yes, we did. Yes, we did. And a lot of science, though.
Yes, a lot of science, too.
Yeah.
It should go together.
Well, I think it does. It's kind of like, I always look at, as tea and cream, it's a good combination. And,
definitely.
See? So, well, I just want to thank everyone that has joined us tonight. Dr. Albers, do you want to say anything? What you got going on?
Well, I'm just writing or I'm trying to figure out what is going on with all these blood moons.
I don't understand that either.
Yeah, I've reached the conclusion that I think they're using holographic projections. I mean,
by the way, I'll just lend you, I have a subscriber, Thorm, who lives in Norway. They didn't see a blood moon.
I'm not surprised because...
He wrote me, he says, where's this blood moon?
Yeah. The thing is, how can we get a pink moon over the United Arab Emirates and a red moon over England? Aren't we all seeing the same moon?
Oh, don't get me started on that now.
We are seeing exactly the same moon. The moon turns red because it's in the shadow of the earth. I actually wrote an article explaining all that. I've written a couple now. So it should look the same. The only difference may be if there's some cloud in the air, some pollution, it may change a little bit, but all the observatories were showing what looked like clear skies. So you should have been able to see the moon. It should have looked the same from every single one, but it didn't. One was pink, one was orange, one was red. How is that possible? Do you know why? I think what they are doing is they using a holographic projection. First of all, I don't think we're seeing the moon most of the time because the sun is not shining and the sun doesn't shine, or the sun's very dim or it has gone off, we wouldn't see the moon. Plus we have the chemtrails that would stop us from seeing the moon properly anyway. It makes a very hazy atmosphere. So they're creating a holographic projection on the moon inside the atmosphere. Not only that, I think we have these objects that would possibly look like the moon at night. They emit light. These are the stellar cores. They're interacting with the atmosphere. They are emitting this pink light or this orange light or this red light. So what they do is they purposely superimpose the holographic projection of the moon. They make it the same color that this of light that this object is emitting, so we don't realize this object's there.
I'm just going to say this from a movie. I smell a rat.
Yeah, definitely.
I smell a big rat. You know, I just, it just bothers me to think that we can be manipulated to such a degree. And it pisses me off, excuse me, to use such blank and crude language, but it just angers me because I keep saying, leave me alone. You know, I'm not messing with you. Quit messing with me. And, you know, why is it that you want all of us dead? Now, you know, when my time comes, Claudia, I'm going to go out with a smile on my face because you know what? I grew up, albeit on the street, but I grew up in the best time. I saw all the great bands. In fact, I was a roadie. You know, I got to see all the great bands. And and I still contend that we went consciously, mankind did. There was something that happened to us. And you know, you can really say that it may have started, you know, potentially with Elvis, but it definitely came out with the Beatles. And our species saw something that we never seen before. We saw this explosion of creativity in sound. And look how it affected us.
Mm-hmm.
Anyway, that's how I see it. So,
okay.
Yeah,
that sounds good.
Well, I mean,
you saw the best bands.
Yes, I did. I actually did.
To tell you the truth, I'm actually like classical music, so I probably missed the best bands as far as I'm concerned, because I like Bach and Beethoven.
Well, you know, I grew up playing the clarinet and the bassoon.
Yeah.
The bassoon is a double reed instrument and is primarily strictly in classical. My three favorite instruments would be definitely the bassoon. Clarinet would be in there as well. I was very proficient in it, but the French horn, and I love the oboe. You know.
Yeah, I love the sound of the cello.
Yeah.
That's, to me, is something special.
See, folks, we are talking here the full spectrum.
Yes.
We're now talking the classics, folks. And listen, I'll just interject this an opinion. If those of you who have parents, if you're not teaching your children music, how to read music, how to begin to understand music, you're doing them a terrible disservice. I mean, I learned, you know what helped me with music? Was math. You know, because once you begin to learn music, well, fractions became very easy for me. You know, is it a 3/4 beat? Is it a 4/4 beat? How does it go? And it was very easy for me to make those connections from that point on.
Okay. Well, I actually learned to read music before I learned to read. So.
Wow.
Yeah, I said that the other day. I learned to read music when I was 5.
You see, I see, I see the connection points. I really do, because it showed right there that you had this gift of mathematics.
Yeah, I had the gift. I mean, my parents found me counting to 100, and I'm not sure if I was yet 3 or I was about 3 years old, and no one had taught me, and I could count to 100. I don't know how.
Prodigy.
I just figured out how numbers work, and I was really, really young.
Well, you see, I believe in the proverb that says iron sharpens iron. So as long as we're here together like this, hey, we're all getting smarter, folks.
Yeah.
Well, Dr. Albers, thank you again for a great week. Get feeling better.
Thank you.
And folks, make sure you go over there and subscribe to Dr. Albers' channel, and give my best to Scott. And we will see
Thank you, Wayne.
Good. And you take care of yourself. And thank everyone here for gracing us with your presence. You know, we do this because we enjoy it, and you make it better. Yeah.
I enjoy it so much. Thank you, Wayne.
Oh, are you kidding? You make the show. I just, you know, I may be dating myself, but Lewis and Martin. I'm a big Dean Martin fan. I always,
Okay.
I really like his music.
Mhm.
My idol growing up was Benny Goodman.
Oh.
I was a real person that really enjoyed the big bands, and then the crooners. Yeah. Anyway, I digress. So,
Okay.
yeah.
Wonderful.
Yes, a very eclectic in my appreciation of music. The only thing I don't really understand, and I know I'll hear on this one, I don't get rap. I just, I I could see my 7th grade band teacher, Mr. Foster. He would not have any part of that. It's like, because it wasn't part of classical music.
Uh-huh.
Yeah. Anyway.
Yeah, I don't get it either. So.
Yeah. All right. So, all right. Peace, everybody. And
Okay.
we will
Bye.
see everyone next week. Thank you, everyone. And be good to yourselves.